Hi, so today I'm going to be going over a board that is working off of the battery but not off of the charger. Now there are a couple of things that can cause this to happen, and I want to go over them today. I also want to go home because I feel sick to my stomach. What are you going to do? First common thing that happens here, first common thing that happens is Open Broadcaster forgets that I want to capture the 4K screen, not the Open Broadcaster screen. Mofo. First thing that happens here very often is that PP3V42 is not working. PP3V42 is a power supply. It's a 3.42 volt power supply that can be powered off of one of two elements. It can be powered off of PP-bus G3 hot, which is the battery, or PP18V5 DCN, which is your charger. So often if it's working off of the charger but not off of the battery, or the battery but not off the charger, one of the things that I would check is to see that PP3V42 is there. On this board, PP3V42 is present. So I'm not quite sure as to why I'm not getting voltage that I'm supposed to. Now, I don't get a green light on my charger, so that's something I'm going to have to troubleshoot via the one-wire circuit, which I've talked about in numerous older videos. So if you don't know how the one-wire circuit works, you should definitely check out the one-wire circuit videos so that you have an idea of what the one-wire circuit is and what it does. So I'm supposed to have SMC, BC, ACOK over here. This signal is supposed to be present at this logic gate so that this logic gate can pass 3.42 volts onto this chip so that this chip can allow my charger to talk to my SMC. This one wire goes to the SMC. So let's measure on pins 1 and 2 of U6901, which means first that I must find them. So on pins, I have to go back because I forgot the numbers of the pins. I can just do this. I can use the nets feature. I hit the N button, and that's going to show me all the points on this board that SMC, BC, ACOK show up. Alright, so that's going to be over there. Now we're going to go over to the microscope here and get to measuring. It's 3. It's kind of going back and forth. And my ISL 6259 is only giving me 1.8 volts on PP bus G3 hot. Now can't be a short to ground on PP bus G3 hot because the battery works. Now, whoa, my head. Alright, so before I put this in the ultrasonic cleaner, there was some schmutzer over there. And that leads to what powers the U7000. So what if the U7000 is not doing what it's supposed to? So I've measured here. I'm getting 4 volts at charger AC in, just to show you what that is for. Let's go to the U7000 circuit here. Whoa, I am dead. One thing that sucks about being the only one that fixes boards at your business is no days off. So, R7010, R7011. The way this circuit works is the power comes into the charger. It goes through here, and then 4 volts goes to charger AC in. Then, after it goes to charger AC in, you get 3 volts in charger ACOK, which I do. Now, I measured 4 volts over there. That's good. After the diode, there's supposed to be a 20 ohm resistor that sends power to the U7000. Alright, so I should, even though I did check and see that there was voltage there, I still should check that resistor, which is what I will do right now. So I check the resistor, and I get 21.73 kilo ohms. Okay, so what did I just check here? So back to the microscope. So that resistor, that R7005. So see, this is the diode with the 3 legs. See this? 1, 2, 3. And then that's the resistor. And then from there it leads to the ISL 6259, which is U7000. Now when I do this, I get 22 kilo ohms. And that's not a recommended value. So I'm going to get up. That was harder than I expected. And get a donor board. and rip that resistor off. And I also might as well get a donor board that has a good U7000 on it, because if there was a voltage spike there, there's a chance that my U7000 chip is dead. So let's just make sure that I'm not losing it and just measure that resistor on my donor board. So when I measure that resistor on the donor board, ohms, which means that it is indeed fucked on this one. Let's turn on the soldering in the rework station. So the rework station is on. That's the resistor. Goodbye. I should wait for my hot air to get hot before doing that, but I would like to get this done as quickly as possible so I don't pass out in the middle of the repair. So we are racing the clock on this one. Okay. Now, we take the resistor from the donor board. By the way, this is why it really sucks to do business like this with other businesses that clean this shit first. Because you see, since I was the first point of contact with this board, I got to see that there was nonsense on that diode, which allowed me to run over to this area. And then when I ran over to the area, I had an idea of where to start looking. That old resistor, like that thing looked, you have to realize that old resistor looked fine. I saw nothing wrong with that resistor. When you look at that resistor post-ultrasonic, you're not going to notice anything wrong with it either. There's a lot of components on this board. There's a lot of pieces that you're going to have to narrow down to, and it's annoying when your ability to narrow it down has been taken away by somebody else. And it adds insult to injury when they make it harder and then they ask for a lower bill than the retail customers that don't make it harder. So if you're sending boards to a place like this and you clean them first, please have the common courtesy to mark the board where that stuff is so that it's easier for us to know what's going on with it. So we have a green light. Baita. And we have a fan spinning, which is something we didn't have before. And again, I'm good at this point. So I'm going to figure that out regardless of whether there's a little mark there. It's just a question of whether I'm able to offer you a turnaround time of this or a turnaround time of who the hell knows. So just something to think about. And that's that for today. So just to go back over to the schematic here. What was wrong with this board is R7005 was blown, and there was some type of liquid damage that was in this area that caused it. This is where the 16 volts comes in from the charger and then goes to the charger DC-in pin of the U7000 chip, which, again, there's no data sheet for this. There's no data sheet for this, so you have to guess on everything. But VDD here has no source. So VDD and VDDP, those are usually the pins that are used to turn the chip on. And the problem we have here is that there is no source for that. PP5E1 charger VDD, that's not created by anything on the machine. Like it doesn't come from anywhere. Or perhaps it does. It does. I'm losing my mind. I need to go home and go to sleep. Anyway, so where I was before I completely forgot what I was talking about is PP charger DC in. This needs to be here, and this needs to be 16 volts. This here can measure... what was I just talking about? This here can measure 16 volts and still not work if this resistor is 2.2 kiloohms. So the way this needs to work is this needs to receive a certain amount of amperage on the DC-in pin. It needs to be able to receive enough energy to power on. So I'm going to open a new incognito window. We're going to go to the Ohm's Law calculator. So 16 volts at 20 ohms has the capability to deliver, let's see, 16 volts, 12.8 watts. Now, let's say that you're at 2,000 ohms. You have the ability to deliver 0.1 watts, which is not going to make that thing very happy. So that's it for today. And as always, I hope you learned something.